Hello. Welcome, everyone. So I have to say that I planned this hearing after a meeting over in the new temporary structure where everyone was just so excited about what was going on in their communities. A lot of it stems from some of us going to Denmark and learning about industrial symbiosis, and we had a bill, and there's some money now to do some cool projects around the state. But I have to say that I haven't walked into this room with this much of Twitter and excitement since the beginning of session. So even today, just walking in here, I feel excitement. And so I'm super excited about today's work session. And I'd also say I think it's really fantastic just how bipartisan this has been. The Denmark trip has been for many many of the delegations that have gone, it's all been bipartisan, and the work in this space has also been bipartisan. And so I'm really looking forward to learning more from you all today about all the cool projects that you're doing. And I'd say let's get moving. So we'll start with David Woodson from the University of Washington. Is he online or? All right. And David, you have about 10 minutes. We are going to try and get people out of here earlier than the regular 2 hours. So,
Gotcha.
All right, please proceed.
Let me share my screen. Okay, that's up there. All right. Hi, everyone. Pleasure to be here. Thank you for having me. My name is David Woodson. I'm the Executive Director of Campus Energy Utilities and Operations at the University of Washington. I was hired specifically for taking on the task of decarbonizing the steam plant here and reinvesting into the energy infrastructure after a long career of doing a similar focused effort at the University of British Columbia north of the border. UW's efforts to decarbonize evolve around lowering the temperature of our district energy system to enable sharing and reuse of energy that our steam system presently doesn't allow us to do. The plan is in essence a fuel switch, replacing natural gas-fired boilers with electricity-powered high-temperature heat pumps. All right, so today's agenda that I'm going to walk you through is just kind of real quick orientation of district energy at UW, what we do, a little bit of the history, and then what are the key challenges that we face as a campus, and then our 5-part energy strategy and what our next steps are. All right. So Energy 101, kind of really straightforward. We burn natural gas to produce steam that through our tunnel system, we distribute out to 170 buildings on our campus, primarily for the purposes of heating our buildings on the campus. The natural gas, of course, is fossil fuel, and that's the 93% of our Scope 1 and Scope 2 emissions comes from that natural gas that we burn to produce steam. And that makes us a covered entity in the Climate Commitment Act of around 85,000 tons on our campus. Cooling, we in the same central plant, we take in electricity, produce cold water, distribute it out to the buildings, extract the heat from the buildings, bring it back to our central plant. But because the steam system temperature is too hot, we're not able to reuse that waste heat from the cooling system, and we just get rid of it through a series of cooling towers and dissipate it to the air. If you walk down the Bird Gully Trail, you hear the waterfalls flowing through the spring, summer, and fall. That's us getting rid of that low-grade heat. So the challenges that we face on our campus really fourfold. Number one, I made reference already, 93% of our Scope 1 emissions is from that natural gas at the plant. So for us to no longer be a covered entity and significantly reduce and decarbonize our campus, we need to address the way in which we heat our buildings, those 170 buildings that I made reference to. Energy efficiency. We have quite a variety of buildings on our campus. The hospital's connected to the system. We have research facilities connected to it. But there's a huge opportunity to be more efficient with the energy, including the electricity that we consume. And you'll hear that in the 5-part strategy. Thirdly, hey, it's great that we're connected to Seattle City Light and that we have clean energy that we're connecting to, but we're constrained. We're right at the N+1 capacity from them. And so the fundamental piece for us is we need to be really smart about the electricity that we use, especially as we're doing this fuel switch for decarbonization. I'll highlight that there's also further pressure on electrical use because of climate adaptation. We live in the mild Pacific Northwest that's not as mild as it used to be. And we have buildings that don't have cooling in them at all that now need cooling today. And typically that cooling is coming from mechanical cooling, which means more electricity being used to produce cold water to cool buildings down. The fourth is all of the infrastructure that we have in our steam plant. It's aging infrastructure that we're going to need to make significant investments into anyway and replace it. So why not invest in a way that actually addresses the first three problems on the list? All right, next slide, little history. Hey, we've had a steam plant on the campus since 1894. There was the first one, 1894, 1901, 1908. Interesting where the lake used to be. I didn't realize the lake used to be higher and they lowered the lake when they built the ship canal. But the existing plant is on the 1908 site. And really what I'm trying to reinforce behind this is there really are smart ideas around having a district system and a central plant that you use that to heat all your buildings on the campus. And this idea of transformational change, well, we've done it before. The original plant used to run off coal that was delivered on the Burt-Gilman Railroad, which is now the Burt-Gilman Trail. And that same transition that we made from coal to natural gas, well, this is just the latest transformation in our district system. All right, and that's the plant present day. So our four-part strategy is addressing those four elements: greenhouse gas emissions, energy consumption, capacity constraints, aging infrastructure. And here we go, 5 parts and their components in it. So number one, we need to be focusing on energy efficiency. So this is, there was a smart metering program that was initiated some 9 years ago. Fantastic. We just need to finish it by adding some thermal meters on our campus to have all of that great data available to us. And inform where the opportunities exist on our project. Secondly, we have some buildings that still have pneumatic controls and older digital controls. We need to upgrade those to modern digital control systems so that we can access the data, which really leads to this data analytics platform. At UW, we have some 50,000 points connected to our data analytics system. When I left UBC, we had 1.2 million. And it's a game changer with respect to identifying energy conservation efforts, places where you might have competing simultaneous heating and cooling. So really, really powerful tool. And fourth, establishing a green revolving fund where we focus on energy conservation projects. We've already started this, spending $3 million a year on energy conservation efforts, focusing on quick payback projects and using the savings from the initial year projects to pay for future years projects. And we are on target to have this being self-sustaining by 2025. The second part, and really kind of fundamental to our strategy, I jumped ahead too, sorry, is converting the campus steam to hot water. So as I mentioned, steam is just too hot and we need to lower the temperature. And we do this by putting in new hot water pipes. And really, this is the enabling technology that allows the energy sharing and reuse to take place, right? We have quite a diversification of buildings on our campus, just like any city would have. And we can take advantage of that excess heat from one building and share it with its neighbor. Secondly, third part of the strategy is this, we have as I mentioned, a central cooling system. We also have a lot of buildings with their own standalone cooling chillers in them. It is way more efficient, i.e. better use of electricity, to have all of that cooling capacity in our central plants, almost by a factor of 2. So the strategy is to increase the capacity of the cooling in the central plants. And as the chillers in the buildings reach the end of the life, we don't replace them, we connect them to the central plant. The other advantage of that is all of that waste heat that then comes back from the cooling system is now available for us to use in that new hot water system to displace natural gas to heat the campus. Now, the only downside of using waste heat from the cooling system is that there's an incongruency of when you use that versus when we need the heat. The least amount of cooling happens in the winter and the most amount of cooling happens in the summer. So it's great for the shoulder seasons, but we need to look for other sources of low-grade heat for the summer and winter. And two that stand out are one, the regional King County sewer lines that run adjacent to both plants. They really couldn't be any closer than they are. And so that's a fundamental opportunity. And the third being the lake, which is really just a form of geothermal, but we know exactly the distance we need to go in order to access that same temperature water all year round. What's interesting about the lake opportunity is it also has, in its early stages, but it has the opportunity for an environmental betterment, and that we could take cold water from the deep part of the lake, use it for cooling on the campus in the summertime, and return colder water into the ship canal, lowering the temperature of the ship canal and improving conditions for migrating salmon. In the wintertime, it would be even better in that we can take cold water from the deep part of the lake, extract heat, return even colder water to the ship canal, and create almost a pre-seasonal cooling of the ship canal. Long way to go, some 19 permits that we need to apply for and go through. So a long process, but a project that has the potential of addressing climate adaptation of increased cooling in the summertime, decarbonization of displacing natural gas in the wintertime, and improving a migratory berry for salmon through the ship canal. Other pieces on this electrified heating piece also include thermal storage, both heating and cooling on the campus. And the final push, the first four pieces would get us to 80% reduction on greenhouse gas emissions. And so we're still going to continue. We still need steam on our campus for the hospital for sterilization and process loads. And so I need to continue to watch and scan the marketplace for technologies that develop over that time period for that final push and that last 20%. Graphically, this is what we're looking at. I know this shows to 2035. Honestly, we're trying to do everything we can to accelerate this and put this more on a 2030, 2031 timeframe. But this is what we're seeing from a greenhouse gas reduction standpoint. Order of magnitude cost of the different pieces, some, $500 million and change dollars. We're very excited by the opportunity of the potential of the IRA federally and the Climate Commitment Act at the state level as being major sources of funding for these efforts. Still trying to get clarity on our status as an instrumentality of the state and our ability to qualify for direct pay under IRA. And so next steps, continuing our efforts that we've already started on accelerating energy efficiency and retaining a service partner to help implement our energy transformation strategy and provide that progressive design coordination across all of those projects. And there we go. Thank you. I think I'm right at 10 minutes, I hope.
That was great. Thanks, David. Any questions? Out? Rep Ramel?
Thank you, Madam Chair. And thanks for the presentation, David. I don't think we've talked much in this committee, and I don't know if we actually have any sewage heat recovery projects in Washington. First glance, that sounds like it could be pretty gross. Can you talk a little bit about how that works and reassure us that it's not?
Yeah. So what you're really after is the heat from the water. So think of all the people that are taking showers early in the morning and all that wasted hot water that goes down the drain. That's the heat that we're trying to capture out of the sewer. And there are some pretty successful projects to look to. The city of Denver has one. They use a company called Shark, which I think is based out of Vancouver, but also is in the state of Washington. City of Vancouver had a sewer heat recovery system from the 2010 Olympics, which they've recently have a project to expand. This technology has changed quite significantly on its ability to not let the solids in the fluids in the stream contaminate the heat exchange process. So people that sort of were in this space 20 years ago. It's a completely different technology play. There's another company out of Ontario. I think it's called Noventa. I might have the name slightly wrong. Really, this is existing technology. It's not it's not a high risk bleeding edge type piece. And at UBC, we were considering this. We were considering tapping into the Iona treatment facility, which was 5 miles away and under the Fraser River. And our context was the permits of running a pipe that was going to lie on the floor of the Fraser River. Here it's right in the street, right beside both of our plants. That's what I'm saying. It couldn't be any closer. It's a great opportunity, if not an obvious opportunity. And the other part is district scale heat pumps that are water-based heat pumps are almost twice as efficient as air source heat pumps. So one of the huge advantages of doing this at a district scale and from the sewer is the ability to use that energy across the 170 buildings on our campus and not having to put individual air source heat pumps in every building. Thanks, Alex. And just running you one other thing. We had Alex out for a tour in the fall of the plant, and we would gladly, anybody who's interested that's hearing this today that would like to know more, would gladly host you for a tour on our campus and go into more detail of what we are planning to do.
Representative Dye.
Thank you, Madam Chair. You had said that a lot of the building's heat systems or the district heat system is nearing the end of its serviceable life. And I'm curious to know, knowing that you have done maintenance and changes, I'm sure, along the course of the life of those facilities, that they're not all ending at the same time. They're not hitting that point at the same time. So is there any way that this project could be phased rather than just dive in 100%?
Yeah, so there's elements of opportunity within that. Definitely not everything is reaching the end of its life at the same time. So we have 5 boilers in the plant. The oldest one is from 1948, so it has definitely seen its best days, right? And but there's 3 newer boilers in the plant, new boilers in the plant. And so the intent would be we would replace the 2 oldest ones first and replace them with heat pumps inside the plant. So there's definitely a optimization opportunity when you do that. But I'd also add that converting the campus from steam to hot water is kind of fundamental. If you don't have that hot water grid in place with all those pipes connecting to transfer stations inside the buildings, you can't. It doesn't matter whether you've got sewer heat or heat from the cooling tower. We have heat from the cooling tower today. We can't use it because we don't have that lower temperature system to put that heat into. So that hot water piece is really transformational, and it's kind of a fundamental first step that has to happen.
Great. Thank you so much, David. Super exciting. Going to move on to Amanda Cambray and Brian Ross from Western Washington University, as well as Mike Hogan from the Port of Bellingham. And just a plug here, my son is a freshman at Western, so I'm excited to hear what's going on there.
Oh, excellent. Well, we're happy to have him. And I'm going to go ahead and share the screen here. And there we go. Okay, fantastic. Okay, and there we go. And let me just here. So yeah, thank you very much for having us, and we certainly appreciate that. This is going to be a similar conversation here, but for starters, this is a joint presentation between us, Western Washington University, and the Port of Bellingham, and we're happy to share what we're doing at both of our institutions. Just so you know, my name is Brian Ross. I'm the Director of Capital Budget and Public Works Procurement. We're joined by my colleague Amanda Cambray. She's the Director of Energy and Sustainability. And we're happy to be joined too by Michael Hogan, who's the Public Affairs Administrator at the Port of Bellingham. Just to note, so this is a similar project, if you will, from what you just heard where we're really converting our heating distribution system from steam to hot water, and it would be a lower base temperature. And I just want to say we really do appreciate and want to thank you. We were happy to see the funding for this, at least for the 23-25 biennium, in the capital budget yesterday. So we certainly appreciate that. We also appreciate seeing that in the Senate's proposed budget, as well as the governor's. The intent, of course, just like at University of Washington, is to reduce greenhouse gas emissions and eventually decommission the existing steam plant where we have some levels of operational challenges associated with running the steam plant. The total project scope. Now, we conducted a study about a year and a half ago, and that was funding in the last, or really in this current biennium. And the study, after conducting that, the outcome of the study, or the scope of the study, number one, is not only just replacing or converting those 3 miles of existing pipes throughout campus, but also what we're doing is a 4 nodal plant system, or what we're proposing, at least at this stage, is a 4 nodal plant system. And there was a question related to phasing. And the advantage with phasing that we've deemed from the study is that it could protect us, especially if down the road, whether funding be an issue or a situation where you can phase various areas of campus, and therefore at least have some portions of the campus benefit from this new infrastructure, and we can gradually get off the steam plant kind of one by one. And you see the comparisons here over to the right. You see the existing infrastructure in the pink, which is really our steam plant, and how all the facilities are connected to the one steam plant. And then you look at the proposed new infrastructure, which you have nodal plants where they're going to be using again, very much similar to what UW is doing, the heat pumps. We would have some backup boilers especially for resiliency in those peak winter days. And then, of course, taking advantage of those geothermal fields. And you can kind of see the just a drawing there here on our campus map. You can see those regions of campus that would have its own individual plant, as well as some of the geothermal fields. And so that's what we're looking here. And that was the outcome of the study. We're going to conduct in the 23-25 biennium, and what we're asking for that was approved, at least, or included in the 3 previous proposed budgets, or the 3 proposed budgets, we would be taking care of schematic design. We'd be doing surveys, testing, and analysis. And then the 2 components that I think is really a big component of our presentation today is we're going to analyze all procurement opportunities. This is a big, huge program. You're going to see that in the next slide. But also consider that, we have to take into account future technologies and even the potential for interconnectivity that we could potentially have with another district, i.e. the Port of Bellingham. And then also one of our goals for the 23-25 scope is to have a full design of one of the nodal plants. And just for all members to note, the website is down below, and I think you've probably received these slides as well. Feel free to go on our website. We have our full proposal as well as links to the study. That's all available there. And I just want to quickly go over. This shows you the magnitude of the program here. It's not just really from our lens a project, it's a program. And that's why things like procurement and making sure that there's a level of flexibility is important. If you start at the study, which was a year and a half ago, you're talking about a 12-year, 6 biennia program. And you can see here in this upcoming biennium, we're going to be looking at the studies, and then obviously having one of the node plants designed. And our big goal is in calendar year 2027, be able to operate the first node. And then when you go all the way to 2033, we're hoping to have all 4 nodes operated, and even by then have the existing steam plant decommissioned. So this is at least our program at this point in time. We're looking forward to the current studies and the current program once hopefully funding is solidified. And from there, I'm going to actually punt this out to Mike Hogan, and he's going to talk about what they're doing down at the port.
Well, thank you, members of the committee. Really appreciate the opportunity to talk about the Port's district energy system for Bellingham's downtown waterfront. This has been a project that's been a long time coming. Started back after the port acquired the Georgia Pacific pulp and paper plant back in January 2005, and begin the transition of that heavy industrial property into a mixed-use development. And folks really realized that the opportunity to connect downtown Bellingham to the water and plan a neighborhood of a future was really a once-in-a-lifetime opportunity. The port was working with the city. It's about 237 acres on the downtown waterfront. And one of the there were many things that went into the planning, but one of the things that jumped out early was the opportunity for a district energy system. There's a Encogen, a Puget Sound Energy cogen plant that historically had supplied hot water and steam to the Georgia Pacific plant. And so it was, once that operation was disconnected, it was looked at as kind of a low-hanging fruit of how could we capture that waste heat from the cogen plant, use it to power new buildings on the downtown waterfront. A big thank you to a lot of folks in our community that lobbied for that type of system rather than kind of business as usual. Sustainable Connections was a great local organization that organized tours for port and city leaders to Dockside Green in Victoria and up to Vancouver to see the systems at UBC and Simon Fraser and False Creek. And that resonated with leaders. We still weren't at a place where, we were ready, we were making the development regulations. So, the chicken before the egg. So how does that work? So as part of those development regulations, language was written that said, if there was a district energy system available, thou shalt connect. And so as we went forward with the master plan and the development regulations, we visioned having a future district energy system. And then the next step was actually, doing the actual engineering work and went through a waterfront utility master plan where we did a district infrastructure study looking at both district energy, but also district water, the opportunity for microhydro and district stormwater. And then when we were putting streets in the downtown waterfront, the first street, the port invested in a 4-pipe system that went under the roads and went out and looked. The ports does a lot of things well, but we're definitely not a utility. So we ended up doing an infrastructure agreement with Corks Utility that's based in Canada. They do a lot of work all throughout the U.S. and the world, really, but as well as a lot of district energy systems. And so we brought their expertise to bear and signed an infrastructure agreement. And they signed their first energy services agreement with the private developer in the waterfront, Harcourt, earlier this year, as well as there's a Mercy Housing project that is going to connect into the district energy system. And so we anticipate the first connection in the fall of this year. And as far as next steps, we're looking at, ways to expand this district energy system to retrofit existing municipal buildings downtown, as well as new developments, as well as potential connections up to Western Washington University. So exciting time. It's been a long time coming, but we are close to having district heat on Bellingham's downtown waterfront. And so now I'll turn it over to Amanda.
Thank you. So that was a great setup from all of my colleagues. David Woodson and I chat regularly about all of the potential technologies and constraints that we share, albeit at a smaller scale at Western compared to his presentation. But I would say that was a great summary of the challenge. The emphasis being converting the system to hot water is the #1 investment in the infrastructure that's going to give both what UW and WW's systems the flexibility that's needed. So as we did our feasibility study, that was the flavor of the day: is how do we make a system that's flexible for new technology that allows our operations to not be interrupted, that allows our mission to continue, and including our mission to reduce our greenhouse gases. So I want to speak a little bit about how the synergy between Western Washington University's conversion and the district's development are working together. And again, timing is everything on these. We have the IRA funding coming available. As David kind of referenced, we need to figure out what teaming and Appropriations, regulations need to be worked out for those. The number one benefit I see in coordinating Western and the port is the investment in the community to have a shared resource. It increases resiliency of both systems. Like I said, adds flexibility. There's some limitations for us geographically on what we can and can't install. So that's where that feasibility study helped hone in what's really possible given the limits of space and thermodynamics and those sorts of things. There's a shared maintenance and operation burden potential depending on how that district is owned and operated. And of course, that partnering and teaming arrangement that adds flexibility to our procurement options. Just to be clear, it's not without some constraints. So there is the question of interconnectability. Is there a thermal loss as we do that connection? What does that look like? What's the investment? Is it really feasible? So that's first pass, but we wanted to make sure that our system is flexible so that we can have that further exploration. Like I said, the steam to hot water is primary, just like David said. We have to convert to that hot water system. Eventually, we'd like to end on a low temperature system so that we have even more flexibility for technologies. And then, like I said, there's additional cost for interconnection, but there's a lot of benefits there. Redundant heating capacity. Also, there's cooling capacity that might be available to Western that would be more challenging otherwise. So just a lot of opportunities to be a demonstration community for Western Washington, the United States, to show that, it's time for us to reinvest in our infrastructure. And not only is it a good investment, but it adds flexibility for future technologies that create jobs and support a sustainable community.
We'll open it up. Happy to open up for any questions or discussion.
Terrific. Are there any questions for our panel? Okay, super exciting. All right, we will move to Rob Duff and Reese Roth. So now we're moving into industrial symbiosis and away from district energy systems.
Should we do this, Rob?
You can sit there? Really? Okay.
You're longer, so you can.
Am I going first there? I thought you were going. Does it work if you go first, or? Well, my slides are up first there, so if we can, what do you think? We better do it that way. You can work. All right. All right. Thank you to the chair and committee. My name is Rob Duff. I'm the Sustainable Business Development Director for the Washington State Department of Commerce. And I'm going to jump right into this. I'm not going to go dwell on this because I think there's some very knowledgeable people on the committee here, but quick definition, and basically what we're talking about is moving into a circular economy where waste isn't treated as waste, it's treated as a resource, and often that requires co-location, but not all the time. We've seen some interesting examples where you can overcome transport and still do this. It's broadly defined as pretty much everything. You see the things I highlighted in the big bullet, but if you look at the initial report that was commissioned by this legislature to investigate what we should do, and then ultimately led to the bill, it includes even things as expertise, equipment, materials that can be shared among industries. There's 4 basic categories that were outlined in that report that Commerce prepared originally back in 2019. You can just do it. You can do it because you have talented people within your industry and your company. You can get some facilitation from people like Center for Sustainable Infrastructure. You can just do it based on data, and exchanges are going to talk briefly a little bit about a database exchange that we want to support and is actually called for in the statute. And then the strategy and planning for major efforts like we saw in the pioneering effort in Europe at Kalundborg, and a lot of you have seen that. That is sort of industrial symbiosis on steroids. It's pretty impressive. It goes all the way to making pharmaceuticals. And so very impressive, and was one of the reasons I think we got what we got here. So here's the legislation, just in case folks want to see where the RCW is. I'm not going to spend a whole lot of time on that. So the funding, so the first year, when the bill first passed, it actually had a pretty significant fiscal note, was vetoed because it was COVID, that was in 2020. In fiscal year 2021, there was only, that should actually be fiscal year 2022, sorry. That was $175,000 for grants, and that resulted in 3 projects. I'm going to talk about those briefly, and then we got a little bit of staffing to support that. In the supplemental budget add in 2022, that allowed us to bump that up to $850,000, and that resulted in 4 very cool projects that you're going to hear directly about too, and I will go over briefly. And then the outreach and communication, done a lot of presentations, various organizations, our ADOs, WIDA, I'll be talking about this again in a couple days at the winter meeting. Various conferences, been presenting this in different international forums set up by our embassies. We set up a webpage. And then I also want to mention that the Public Works Board, I think most members here know that the assistance account is pretty substantial. And we're thinking about how to capitalize on some of that money and innovate towards the things that needs to fund, a very important account for our municipalities. But we think we can combine some of that money with some innovation like we've seen at the City of Pasco, and you're going to hear about that but from Steve Worley later. So City of Pasco, I'm not going to talk much about that. We had a first interagency agreement with them to help them figure out how to continue handling all that food processing wastewater and not run into problems with the Department of Ecology and nitrate and groundwater. Some really interesting stuff I think you'll hear from Steve. And then that is also getting ready for a $600 million investment from Dairy Gold. So they're going to get another 300 or 400 million gallons of wastewater. And they're not just expanding their ponds and their systems and their pipes that bring it in. They're trying to think innovatively and get an extra benefit because algae can provide that. They can actually do the denitrification cheaply and actually provide that secondary benefit. Also provided some money to look at the combination of fly ash and biochar to Tim Murray and Steve Van Vliet at Washington State University. They worked with both Inland Empire Paper and Qualterra, who you'll hear from later, and got some really exciting results that Qualterra will show that when you use biochar by itself or in combination with fly ash, you can reduce the acidification of soils, which then removes that stunting of the growth and gives you bigger yields. And finally, in our first year, we provided a grant to Manuel Garcia Perez to take biochar and see if it can stick hydrogen sulfide, mercaptans, and ammonia, because as we get ready for House Bill 1799, we're going to do a lot more composting, and there's nothing that will put the brakes on composting than odor complaints by people that live nearby, and I think we all could probably understand that. Here are the projects. Inland Empire got a competitive grant that actually is trying to take that fly ash and prill it so that it can be delivered through a seed drill and existing equipment. Very important. We don't want to cause farmers to have to buy another $100,000 piece of equipment. And so they're trying to prill it with material so that it becomes something that you can actually easy to use by the farmer. You're going to hear from Qualterra. They were also one of our recipients, so I won't dwell on what they're talking about, but they've got some really impressive results with both apples, hops, and wheat. Minocarbon, you will also hear from today. They have an interesting project co-located up at Kettle Falls at the biomass to energy plant. So they already have the slash coming in. So that's important. They're not going to have to bring in through trucks a different transportation system. So they're going to make biochar out of some of that slash. And then also an R&D project that they're working with PNNL is, can we find a new liming agent? Lime is really expensive, and we're sort of falling behind in trying to deacidify our soils. So if you actually capture the waste CO2 as you're capturing the energy, scrub the basalt, it's possible that we can create a liming agent that can also help farmers. And then finally, Impact Bioenergy is going to take their anaerobic digester. They're installing pipes that will get a nearby farm off of natural gas and onto their RNG, and they will capture that waste heat, bring it back, dry the digestate, and use that as fertilizer. So those are our first 4 projects. We're pretty excited about those first 4. That's the 850 that you guys helped provide in that bump up in the supplemental budget. And then finally, a couple other things just to mention. The Washington Materials Marketplace, I had said up front, it's like a clearinghouse, so you really need to know where all these materials are if you really want businesses to capitalize on them. And I'd like to call it a Craigslist of all of this material, but it will be transactional. It was recently purchased from a nonprofit by a for-profit company, Reapley. They want to make it actually transactional, and once that happens, hopefully it'll really take off because people will start making money, they will put more money into it, and so that's one of the things that was called for in the statute. We hope that takes off. Beta Hatch, some of you may have heard at Wenatchee, they use waste heat from a cryptocurrency operation to grow mealworms that will be useful in feed for livestock, really, and we're going to hear a little bit about that. And then finally, Next Cycle Washington is mostly about the curbside stuff, but actually does get into some really interesting projects, and they're actually really good at not just giving out grants to the usual suspects. They really are going down into the communities and getting small grants to actually make sure that, you know, everybody gets to play in the circular economy. So that's a quick overview of what we've been doing with the excellent legislation and financial support that you guys have given Commerce. And I'll turn it over to Reese.
Awesome, Rob.
You got some more cool stuff, Reese?
Well, I'm mainly going to talk about how cool you guys are, but I'm Reese Roth, Executive Director, Center for Sustainable Infrastructure. Thanks so much. Really appreciate you organizing this work session, Madam Chair and Representative Dye. It's terrific and very exciting. If you can do, I can do this, right? Boom. This whole concept of industrial symbiosis, which seems kind of exotic, you know, and foreign, but it's really, you know, gained incredible traction over the last few years. It originated in Denmark, and in 2017, 2018, 2019, we were privileged to join a number of legislators on tours in Denmark where this concept of industrial symbiosis was born 50 years ago in the city of Kalundborg. These are the legislators that we joined with, and I know some other folks have gone on tours in Denmark in addition. Huge thank you to the Scan Design Foundation for enabling legislators to participate in this and provide scholarship funding. Big thanks to our friends at iSustain for organizing those 3 trips. You'll notice 26 state legislators, 13 Republicans, 13 Democrats. Just demonstrates that this is the kind of concept that we can come together in a bipartisan way and that can benefit communities of all shapes and sizes in all parts of our state. And so everyone who went on that trip got to visit Kalundborg, which 50 years ago initiated the world's first industrial symbiosis, and it's really going strong 50 years later. There's something on the order of 25 or 15 industrial facilities, public and private, that are sharing energy, that are sharing water, that are sharing material waste flows in ways that those become secondary resources. And with those 25 resource sharing agreements, every one of them is mutually economically beneficial for both parties involved, for all parties involved, and deliver sustainability benefits. So I think this is kind of the power of the concept of industrial symbiosis, is that industry benefits and increases profitability, lowers costs, reduces risk, and you get great environmental performance at the same time. So when those come together, I think, you know, we can make great things happen. So what have they been able to achieve? They're generating about $28 million in economic value per year. Now, this is a town of 17,000 people, so that's, you know, $1,700 for every man, woman, child in that community that is being generated just from the symbiosis of these facilities, reducing greenhouse gas emissions by the equivalent of 600,000 tons a year of CO2, They've gotten their local energy supply carbon neutral, and they're recycling something on the order of 68,000 tons of material. What you've been able to achieve here in the Washington State Legislature is leading the nation. Every one of the last 5 legislative sessions, you've either been able to pass funding to help spark and support industrial symbiosis projects in Washington State, or you passed a major, the nation's first industrial symbiosis statewide program that Rob just described, that's providing grants for all kinds of entrepreneurial efforts in communities all over the state. In 2022, you even passed a $500,000 proviso for Washington State University to look at the application of industrial symbiosis, best practices and principles to the agriculture sector. How can it benefit agriculture? How can we scale that up? And then in October, I was privileged to go back to Kallenborg, where they had the 50th anniversary of the origin of that industrial symbiosis, and I was able to tell the story of what you've achieved here in Washington State, which was really exciting, and folks were very, very inspired to hear about it there. And in fact, the Danes are investing in Washington State. They're offering industrial symbiosis trainings for folks who want to learn how to and get skilled up in terms of how to facilitate industrial symbiosis projects in your communities. So that's coming up in April. That's open to anyone who wants to go through forced 2-hour sessions, and you'll come out with a lot of knowledge that you can bring to your community to help spark projects. You're going to hear from a few projects that are happening in Washington State, but just through your leadership in investing in this program, you've inspired a lot of companies and a lot of entrepreneurs to look at their opportunities and to develop industrial symbiosis opportunities in all kinds of communities. So you'll hear from a handful today. There's a whole lot of others. We're working closely with WSU around this agriculture symbiosis report. We're going to come back with recommendations on that in June. In the process, we're talking to dozens and dozens and dozens of companies and innovators around our state. So there's a whole lot of energy and innovation that is being hatched. We're early stage compared to Denmark, but we're learning fast and developing quickly. So thank you so much for everything you've done on this, and get ready to hear from some projects.
All right. Any questions? Representative Barnard.
Thank you, Madam Chair. Do you think it will take 50 years like it did in Denmark? I mean, hopefully we can cut that in, what are you thinking? How many years?
Well, we're already seeing projects take off. They're small scale compared to Denmark, where they've developed this over 50 years, but we're going to see action. What the city of Pasco, they're looking to break ground within the year. Just talked to Pacific Ag and Sunnyside. They're looking to break ground in the next couple months. There's all kinds of things happening. So it's going to grow in scale. We're going to, companies are going to build know-how and expertise over the coming years. So I think in 5 years, you're going to see quite a bit of industrial symbiosis action on the ground.
And I can't wait to see the bug farm.
All right. You're going to hear from them. Yeah.
Any other questions? Okay, great. Let's have Lauren, who I think is here in person. I think you're the only one in person, so let's start with let's start with you, Lauren. Hello.
Hi.
Nice to see you.
Good to see you all in person. All right. I came here on a beautiful sunny day in Port Angeles, so it's worth it. Do I need to pull it up, or?
I'm sorry, Leo. Did I go out of order and then making it harder for you?
Oh, it's no problem. Just give me
Because we can start with Virginia if that makes it easier for you.
I think she's on a time limit too.
Okay, so I'm sorry, Lauren.
Good.
You could just stay there and we'll start with Virginia.
Oh, hello.
Hello.
My presentation.
Hi. I'm Virginia Emery. I'm founder and CEO of Beta Hatch. I apologize. I don't have any other visuals, so you just get to hear from me directly. But what I will say is if anyone is in the area of Kashmir, Washington, and would like a tour of North America's largest mealworm farm, I'd be very happy to show you what we've built here. So Beta Hatch, for those who don't know, is one of the world leaders in the production of insects. We're focused on the mealworm. It's a type of beetle. It's not a pest. It doesn't fly, doesn't really smell or make noise. It's very nice sort of crop to grow. We're very focused in supporting the agricultural industries. We do that with our mealworms as a high-fat, high-protein feed ingredient, focusing on mostly on poultry right now, but also a lot of potential in aqua feed, in pet food, and other livestock applications. We also produce frass, your word of the day. Frass is the insect manure, the co-product of our production. We say frass happens around here. And we have been finding some really valuable uses of frass as a soil builder and a plant stimulant. We've done some work with the USDA tree fruit group here in Wenatchee and found that frass is one of the few things that can help with replant disease, one of the concerns in a lot of tree fruit production. We've done work in hops where we've seen the flavor profile of the hop improve with frass application. We've tested with grapes and a lot of other specialty crops that are obviously very important to Washington State. So our business is not only very unique in what it does, but also very unique in its approach to production. And this topic of industrial symbiosis is very near and dear to us. We, through the support of the Clean Energy Fund, were able to build out a very unique waste heat recapture project. So we are the only insect farm fueled by 100% by waste heat. So we do not have heating at our facility. It all comes from servers at a data center next door. That is a model that we expect we can replicate. If you think about the business in Chelan and Douglas counties where we're located, you have a lot of tree fruit and you have a lot of data centers. And so we have some interesting synergies with both of those types of business. We are right now in an old juice factory. We have a brownfield approach to production. So our whole thesis is really around sustainability. It's driven a lot of the customer and consumer interest in our products, and it's sort of the DNA of what we do. So instead of building new structures, we're finding old structures to retrofit and turn into bug factories that can support local industries. We do that support in two different ways. One, of course, on the product side, as I mentioned, serving animal feed and fertilizer and soil and plant amendment types of customers. But then also on the input side as a processor of organic waste. And the project that we are currently in the process of planning out is an expansion with another type of partner, a food waste partner who's also a grower. So with Dovex Crunch Packs, they own a variety of different parts of growing and storage and processing of apples. We take apple waste, the apple cores from their slicing operation and other reject slices, feed that to our insects, and then they take the frass and put that right back on the orchards in a very literal circular economy closed loop. So we're very excited with that supplier and customer to also now enter a partnership agreement where we'll be converting an old controlled atmosphere building in Wenatchee as our second location. So that's a project that we are in the planning stages of. We're hoping to continue that work and accelerate that work this summer. What that will allow us to do is to get our company to a profitable place. We've been a very rapid growth stage startup, and we're needing to access different types of capital. So this project is going to really be a validation of all of the pieces of synergy, industrial symbiosis that we've worked on, and sort of laying a good foundation for other project finance to come in to help scale our operation and serve a lot of other needs and partners like Crunch Pack. There are multiple small and medium organic waste sources throughout the state and really throughout the country where you're processing these specialty crops, fruits and vegetables, leafy greens, and our insects are an excellent way to move that waste up the value chain. When we think about the waste hierarchy with landfill at the bottom, we have compost, animal feed. What we do sits above that. Obviously getting that into humans, if we can, is the highest value, but we're sort of just above that in part because of the carbon footprint that we have. We can produce our insects, our proteins with 93% fewer greenhouse gases than other types of protein ingredients. So when compared to fish meal or soy meal, other animal byproducts, even other insect producers, Beta Hatch is producing with 93% fewer greenhouse gases. So we're really getting those calories back into the food system faster, but also doing so with a lot less impact on the environment. As I said, we're in Central Washington. We've been able, so the funding from the Clean Energy Fund was at a very pivotal time for our business. That allowed us to secure a lot of additional capital in our Series A. To date, we've brought over 20 million in private and strategic finance into Central Washington to build out and scale our company. And we anticipate bringing a similar volume of capital for this expansion that will allow us to really establish Washington as a key place for this new emerging sector. Insects are one of the fastest growing components of the animal feed industry. We're seeing as high as 35% compound annual growth rate of the market demand for our products globally. So and we ourselves have far more demand than we can supply. So I'm really excited to put Washington on the map for insect farming because I do think that it's a fantastic, it's been a missing hole, missing piece of closing the loop in a lot of our supply chains. In nature, insects are nature's recyclers of organics. They recycle organic waste, and they're the base of most food chains. And that is what Beta Hatch is working to put back into our food system and into our supply chains. Thanks.
Super cool. Any questions? Representative Rammel.
Thanks, Madam Chair. Yeah, super cool. And honestly, I had no idea. This is good to hear about. Thanks for the presentation. How much of that 93% reduction in greenhouse gases is enabled by the energy efficiency from the waste heat? And how much of that is other sort of system efficiencies that would happen if you were doing this same kind of insect farming but didn't have access to the waste heat?
That's a good question. We obviously can't fully, what we can say is we have half the power needs at our location because of that waste heat. So we've cut that piece of the footprint in half. When compared to other insect producers, we're 84% more efficient. So I think that is a big driver. But a lot of the impact of what we do is driven by the feedstocks that we choose and how far they travel. So the fact that one of our current feedstocks, these apple cores, they travel less than 2 miles. The sort of footprint of that is very, very small relative to a lot of other inputs that travel hundreds of miles. Our frass also gives us a boost because in replacing chemical, fossil fuel derived fertilizers, we can actually have a very material impact on the total carbon footprint of all the products that we're replacing.
Other questions? All right. Thanks so much.
Thank you.
All right. Are there any other online that have any time constraints, or should we move to Lauren? Okay, Lauren, you're up.
Hey.
Minocarbon, Beta Hatch minocarbon.
Words. Well, thank you all for having me today. I'm Lauren Brainart, Policy and Partnerships Director with Minocarbon. We are a startup in Washington State, and our business model is to mitigate climate change. And we do that by building large-scale carbon removal facilities that intakes sustainably sourced timber waste residuals from in-woods residuals, slash piles, as well as mill residuals, and convert that into biochar, as well as as a byproduct produce renewable electricity. In the process, we mitigate wildfire risk by taking those slash piles out of our forests. We sequester carbon in the form of biochar, and we're creating jobs in our rural timber-dependent communities. This is an infographic of our facility. I guess for quick background, for our first facility, we will be intaking around 200,000 bone-dry tons of in-woods residuals, DNR managed lands, slash piles from DNR managed lands, U.S. Forest Service lands, taking that to our facility to produce 40,000 tons of biochar and about 18 megawatts of baseload renewable electricity. Our outputs, in addition to those two revenue sources, are carbon removal and avoidance credits, which we are working with a large corporate buyer in Washington State. We're really excited that our first large-scale carbon removal facility will be in Kettle Falls, Washington, adjacent and integrated with Avista's existing Kettle Falls generating station. Once online in end of 2025, early 2026, it will be the largest carbon removal facility in North America and the largest biochar production facility in the United States, bringing jobs, clean electricity, and sequestered carbon into Northeast Washington. Quick overview for those who don't know biochar. Biochar is a highly porous, stable carbon that when put into the soil sequesters carbon for up to 1,000 years. Also, when put into the soil, it retains nutrients as well as water retention capabilities in the soil and has shown to increase crop yield, particularly in sandier soils, particularly in dryland wheat farms, for example, in eastern Washington. Growers can also receive federal incentive payments to apply biochar and soil carbon amendments, as well as receive downstream carbon credits. Our core market segments for biochar are within the agricultural and potting media space, as well as it can be used as an additive to anaerobic digesters, increasing methane emissions and output and decreasing emissions from the facilities, as well as a low carbon building material, stormwater filtration media, and then also an animal feed amendment, reducing the end emissions, particularly within cattle. Mino has been a business in Washington State for 2 years, and we have hit the ground running, collaborating with a host of state, NGO, Commodity Commission, and tribal partners, whether that's applying for USDA grants or research projects here in Washington State, which I will go over. We have gained a lot of traction and partnerships over these past 2 years. Partners really excited about both our facility's ability to intake waste feedstock and biochar as a regenerative soil amendment. Particularly, we just won a Washington Sustainable Farms and Fields grant in partnership with Stevens County Conservation District, Colville Tribes, WSU, Avista to apply what we're calling lime char onto 8 farms in Northeast Washington. The lime char product is a biochar and fly ash from Avista's Kettle Falls generating station. Those trials will go on for about 2 years and will hopefully support our biochar market development once our facility comes online to produce about 40,000 tons. We're hoping to do many more crop-specific trials over these next 2 years and are looking for federal and state dollars to continue these efforts. This is a photo actually of last week with WSU and Stevens County Conservation District and the lime char pile at Kettle Falls. We also won a Commerce Industrial Symbiosis grant in partnership with PNNL to research how we can capture our stack biogenic CO2 emissions and create a byproduct of weatherizing basalt to create a liming soil amendment as another regenerative agricultural amendment. This work is continuing this year, and we hope to continue these R&D trials in the next year. We are also working hand in hand right now with DNR on a couple fronts. One is we're working with the Colville, their Colville Regional Office to determine how much in-woods residuals we can procure regionally to reduce wildfire risk in a high wildfire-prone region. And then we are also working with DNR to think through a pilot of them working with their agricultural lessees to apply biochar to support soil carbon sequestration and regenerative agriculture on their lands. And then also thinking through how we can incentivize slash pile removal and utilization to reduce wildfire risk, reduce regional air quality concerns that slash pile burning causes in the region, to generate revenue for DNR. DNR could get carbon offsets from mitigating slash pile burning, as well as applying biochar into their agricultural lands, and then job creation in our rural timber communities. Just to name a couple policy gaps and opportunities, I think greater incentives for biochar application, whether that's through increasing Washington's Sustainable Farms and Fields program or other monitoring trials and product development, as well as creating incentives to remove and utilize those in-woods residuals for a climate and economic benefit, something around the lines of a direct pay program to entities like Mino and Avista for taking those in-woods residuals, which is more costly than just trucking in mill residuals, for example, and has a greater climate and economic benefit. As well as supporting biochar production facility development. I think we've heard a lot about the Industrial Symbiosis and Clean Energy Fund programs. We hope to see those expanded, as well as increasing the grant threshold. And all of these combined, I think, through the Commerce's Industrial Symbiosis and Clean Energy Fund and other programs such as the Sustainable Farms and Fields Bill, we're definitely seeing a big push in Washington State of businesses investing in carbon removal and industrial symbiosis, and we hope to continue that. I guess the last thing I'll note is we're building our first facility. And it should be up and running by 2026, and we're hoping to build 4 more in Washington State in regions that have, feedstock capacity, downstream biochar application, and then connection to the grid. So we are all eyes and ears around, figuring out where those next facilities are, and we hope they're in Washington State. Thank you.
Representative Couture.
Thank you, Madam Chair. Thank you, Lauren, for that presentation. I think it's great. How much does it cost to establish your first facility? And then when are you setting up shop in the 35th District? Thank you.
Yeah, so our first facility, we're still nailing down our final engineering, but it'll be about 150 to 200 million. And that's due to both the gasifiers and then also the technology to connect to the grid. We actually were looking at a site in your county and are looking at multiple sites in the region. So still sorting that out.
Thank you. As long as my county's at the top.
Right on.
Representative Gaynor.
Thank you, Madam Chair. So I'm curious, you had a contract there for 800 tons. So where did that come from? Who produced it? And
yeah. Good question. So we are, for this first trial, we're in a partnership with Avista. So Avista currently actually produces a biochar product. They just re-inject it into their boilers. It's called re-injection char to create more baseload renewable electricity. So we're actually putting a separator with Avista on their re-injection system to separate out the fly ash combined with the re-injection char to create a fly ash biochar product. Farmers in Northeast Washington that we've been talking to, we could only work with 8 farmers. We got over 40 requests in the region that we are in for it, because the fly ash can be a liming agent and the biochar has the benefits that I mentioned. So 800 tons, but Avista can produce many more tons beyond that.
Thank you, Madam Chair. So I've been involved with experimental, trying to get it off the ground. And I guess I'm just, what seems to be the greatest impediments to getting this up and running?
Yeah, I mean, for large scale biochar production, I don't think we've seen it to the scale that it needs to be. And I think the factors that have changed this is a strong interconnect. Our model is we're doing it large scale. So partnering with Avista to send them baseload electricity is a significant part of our business model, finding similar symbiosis models. I think carbon credits have opened the door as a secondary revenue source to supplement. And I think the largest impediment to biochar at scale is the market development. We're in talks with large fertilizer, large agricultural, large box store companies that are really interested in the product, but it's been at such a small scale that we're having to start doing those trials, product development trials around biochar enhanced fertilizers, around biochar amended potting soil. So I think there's a big push around developing out those markets. So I think funding towards R&D for that market development and demonstration will help catalyze it. And I think large corporations such as large fertilizer companies and potting media companies that are beginning to realize that one, biochar can be a great additive to their mix, but also they're being asked to reduce their scope 3 emissions is starting to open the door towards greater use.
Thank you.
Representative Couture had a quick follow-up as well.
It just occurred to me, thank you, Madam Chair. Once the plant is established, what is the goal for energy production? How much do you think, how much power do you think you're going to be able to produce just from that one site?
Yeah, so our facilities are primarily engineered to produce biochar, right? We're not a biomass energy facility, or else we'd be solely trying to create as much energy, steam as possible. So we'll create 40,000 tons of biochar, and in the process, we'll generate steam that Avista will generate 18 additional megawatts of electricity. So that is going to be our model moving forward. It'll probably be 15 to 20 megawatts of baseload electricity, as well as 40,000 tons of biochar. And Avista, and the reason we're partnering with them is we won their All Resources RFP, where they were looking for projects to increase their renewable energy portfolio to meet CETA obligations. So we are one of their projects to meet those thresholds. Yeah.
Representative Rammel.
Thanks, Madam Chair. You mentioned the carbon offsets. Last I saw, correct me if I'm wrong, I don't think Washington currently has a protocol for biochar credits to sell into our offset market.
Correct.
Is that a priority in your mind? And how does that sort of fit into the economic viability of these projects?
I think if Washington State allowed it, I think it could expand facilities like ours. I think there should be greater expansion of carbon offset criteria. I know you're following California, but I think including carbon removal projects or carbon removal options such as biochar could really support facilities like ours. We are selling our carbon removal credits in the voluntary marketplace and probably in an agreement with a large corporate interest in the state. So for this particular project, no. For future projects, I think that would greatly open the door, and I think it would be one of our recommendations.
Thanks. Super helpful. Do you happen to know what price you're selling those at and how that compares to the Washington market price?
We are selling, so carbon removal credits are significantly higher. So it's about upwards of 150 plus. So I think there's that difference is carbon removal credits are more costly. And so that's one of the factors to take into consideration. Yeah.
Great. All right. Other question? Oh, you have another question. Rep. Street.
Questions, actually.
You can ask two.
Thank you. Thank you, Chair Dolia. Just so I understand correctly, so through the process of heating up plant stuff, basically, you're not only netting energy, you're creating the biochar stuff as well, and the netted energy is in the form of steam or electricity, or you would need, say, neighboring power plant to turn that steam into electricity? Is that
Correct.
general?
The latter, yeah. So we take in the fiber, right, which is all waste timber. We're not cutting down trees for this, right? So slash piles, mill residuals that would be landfilled, we're taking that in through a process of pyrolysis gasification, heating that up at a certain temperature to create that super porous kind of charcoal wood. And then in the process, Avista sends us hot water that generates steam to then sends to their boilers that turns their turbines. So for this, our original model, which is actually, we were looking at a site out in the 34th, which we're still considering, is setting up our own electrical generation, but there is a huge lag time in getting interconnect that it would take, many, many years for our facility to get off the ground. So this partnership makes it streamlines and expedites the timeline. So we send the steam to Avista, they generate their turbines and generate the baseload electricity.
Cool. So where I'm going with this is apparently a bill keeps coming around here about hog fuel, which my understanding is burnt wood pieces. Have you guys heard of that at all? Is there a chance that that could be
Yeah, that is one of our
feedstock for you
feedstock.
guys?
Yep, that is one of our feedstock from the local mills. We were supportive of that. I think it was a tax exemption for hog fuel. I think greater incentives to utilize waste for a climate and economic benefit is super important. We would be one of the purchasers of regional hog fuel in our area.
Thank you.
Thank you.
Representative Dye?
Simple question. So what is the original source of the heat for the pyrolysis? Are you somehow just heating up the wood somehow?
Yeah, good question. So we will be a 24/7 facility, just like Avista. So first day one, we will be probably using, I think it might be our natural gas that is there as a backup in case anything goes wrong to start up the facility. And then the pyrolysis process will be generating the electricity to continue it. So we will not have, it'll be sustained through that.
Okay, any other questions for Lauren? Awesome, thank you so much.
For your time. Appreciate it.
Yeah, all right. Steve Worley is remote from the city of Pasco. Are you on, Steve?
Yes, I am. Can you hear me okay?
Yes, we can. And now we can see you.
Oh, okay. Sorry about that. Thank you all. Let me see if I can share my screen. Trying to figure out which one it is. Going? Nope. Let's see. I don't know which one it is.
I'm able to share your presentation on this end.
I think we can share it technically on this end.
Okay, that would be great. I don't know why it's not showing up. And it'll probably be better on that end because there's a video that I think is more powerful than anything I could describe. So let me begin. Thank you all for inviting the city of Pasco to attend this event, and we very much appreciate it. This is about Pasco's process water reuse facility, and you'll hear me refer to it as the PWRF. That's how we affectionately refer to it as. This is a process that's been in effect or in operation for over 25 years now. How about the next slide? Just so that everybody's aware, what we do is we have 6 large food processors that use a lot of water to wash all the fruits and vegetables or make the food products within their facilities. We have their wastewater pumped through 2 different pump stations to our process water reuse facility. And we process about 1 billion gallons of wastewater each year. And we are looking to increase that by more than double with some upcoming growth in our existing processors and with the new Dairy Gold plant. Next slide, please. This is a photo of our existing plant and our existing site. Most of what you see in this picture are lined storage ponds. Since we use the wastewater for irrigation purposes, we cannot irrigate the fields that the city owns through the wintertime. So we take and we store all the food processors' wastewater during the winter. And then in the spring, we empty the ponds and put the water out on the fields. Now, it's hard enough to get a scale of what this looks like, but I don't know if you can see it, but there's a call out called Screens Building. That is a 2-story building that holds our 2 rotary drum screens. Yep, that one. So just to kind of give you an idea of how large these ponds are. And we are looking to triple the amount of winter storage based on the upcoming improvements. Next slide, please. This one is a very busy slide, but it's intended to show where the processors are in relationship to the reuse facility. The picture on the left are folks that are to the west of where the facility is. It's about 2.5 miles west on the other side of Highway 395. A lot of people will see this as they come south into the Tri-Cities area. They'll pass a lot of these processors as they come into Tri-Cities. The other one on the left is to the south of our facility, and it's about a 4.5 mile journey for the wastewater to get pumped all the way up to our facility. And then from the facility with the green arrow, it shows that all of the wastewater we received after we screen it from organics and try to get some of the silt and sand out of it, we irrigate over 1,850 acres of farmland that farmers grow crops on that help take up nitrogen and clean the wastewater before it goes into the soil and the ground. Next slide, please. So that's an overview of the existing system. So what I'd like to do is show you a little video of what the proposed system looks like. And if someone could show that, that would be great. Much better on your end than it would be if I tried to show it on my end. I've tried it before, doesn't work very well.
I think we got you covered. Leo?
Awesome.
Yeah.
Welcome to Pasco and Tri-Cities, Washington, the agricultural hub of the Pacific Northwest. Easy access to air, rail, water, and truck freight facilities are the reasons that Pasco has experienced tremendous growth in the agricultural food processing industry. Pasco is home to major food processors like Reese's, Twin City Foods, and the massive Pasco food processing plant. Dairy Gold recently broke ground on a $500 million butter and protein powder milk processing plant in Pasco that will open in early 2024 and employ more than 200 people. It's the company's largest ever capital investment. Well, as you can imagine, the food processing industry uses a lot of water that needs to be cleaned up and disposed of, and that's where the city of Pasco comes in. For the past 25 years, these industries have sent their used water to Pasco's industrial water recycling facility, where it's cleaned and then used to irrigate crops like alfalfa, corn, and potatoes. With the food processing industry growth and Dairy Gold's new plant, the amount of water needed to be processed will more than double. And that's why Pasco's water recycling facility needs to be expanded. This expansion offers the perfect opportunity to incorporate industrial symbiosis into the upgraded plant. Industrial symbiosis is the concept of using water from one industry and then turning it into a beneficial product in another industry. And the proposed expansion of Pasco's reuse facility will create 3 beneficial products from the processor's wastewater. First, the water will be cleaned through a process that creates methane. The methane will be captured, cleaned, and sold as renewable natural gas, or RNG. Second, nitrogen in the water will be removed through a rotating algae biofilm process. The nitrogen-rich algae will be collected, dewatered, and then turned into nitrogen-rich fertilizer that will be sold to local farmers. And third, the clean water will continue to be used for irrigation of over 2,000 acres of crops. Pasco is leading the way in redirecting wastewater away from the sewer treatment plant and using those 2 billion gallons per year of food processed wastewater to create RNG, fertilizer, and irrigation water. It's industrial symbiosis at its finest. If you have any questions about the processed water reuse facility, please contact Public Works Director Steve Worley via email at worleys@pasco-wa.gov or call 509-543-5738.
So that's a quick overview. It did a much better job than I could have. If we could go to the next, or go back to the slideshow, I wanted to show, as part of the nitrogen removal process, the rotating algae biofilm. I wanted to show this photo. It's part of a video as well, but we won't show that video. It's basically a series of rotating vertical belts in a very large greenhouse. And those belts just rotate through the wastewater. They take carbon out of the air, and they use the nitrogen and the carbon to grow algae. This system automatically harvests the algae into a place where it can be dewatered and then turned into fertilizer. Each of these units that you see here in the concrete basins is considered one unit. There are 10 belts in each unit, and we have 13 units planned for our facility. So that's 130 belts. One of the advantages that we have with this system is the potential in the future for being a feedstock for potential biofuels as well. The company that has developed this system has been for a year or so sending samples of this algae to the Pacific Northwest National Laboratory, because they are using this algae for biofuels program. They can pressurize and put heat on this algae and turn it into crude oil. So it's fascinating, the potential options that this program and project will provide. And so with that, I'd be happy to answer any questions. I do want to say also that thank you for the funding for our project in the draft budget. That's awesome, and hopefully that works out. I also want to do a shout out to Reese and Rob at CSI and Commerce. They've been extremely helpful to Pasco and helping us get funding for researching this project and getting the information out there. We're just really excited about being able to take the wastewater that was used just for irrigation and turn it into several other products and get the benefits out of that wastewater that hadn't gotten out before. So with that, I'm happy to answer any questions.
Representative Gaynor and Representative Gaynor. Sorry.
Thank you, Madam Chair. So Steve, with the water then, that's just like gray water, or just the processing water, and where else does that come from? And is there any nitrogen in that water that's being applied on the crops?
Yes, it is just wastewater from the food processing. So it's no regular wastewater that would go to the wastewater treatment plant. So it's just wash water, basically, or water used to cook potatoes, wash the vegetables, and then they send it to us. And so it's easy to treat. It's easy to use as irrigation. The problem we have right now is that it has a tendency to cover the crops with a little bit of a film because the water doesn't get treated very well. With the new system that we're proposing, we anticipate the water will be much cleaner with the anaerobic digester and the nitrogen removal. To answer your other question, yes, the water comes to us with high levels of nitrogen, higher than what is in the groundwater. And so that is the reason we are needing to remove the nitrogen from the wastewater, because we only have so many acres of land to put the water on, and we're limited as to how much nitrogen we can put on each field each year. And with all of the wastewater from Dairy Gold and all the other processors that want to grow, it's more nitrogen than we can put on the fields, so we have to remove some.
Sure.
So then it is that you basically are doing some fertigation with this water. Is that correct then?
Yes,
Okay.
it's actually, we take out some of the nitrogen, but it is nitrogen-rich water, which means that the farmers that lease our circles do not have to fertilize their fields.
And then I'm just curious about the delivery of the water from the ponds that you have, then it's tied into is it an irrigation district, so to speak, that you're delivering to the growers?
Nope, it is, we have a separate pump station that all of the ponds drain to a pump station, and we pump the water through pipes out to 14 circles, and each circle has a pivot on it. And we have a manifold system on each one where we can switch from reuse water to groundwater at the touch of a button. And so it's our way of doing the final treatment of the wastewater through the plants and the soil, but then it's also our way of disposing of the water. It was difficult to think about sending 1 billion gallons of water a year through our municipal wastewater treatment plant when we didn't have to. And so this is our alternative to having to build a much larger municipal wastewater treatment plant. And we think this is a much better alternative for all of our processors.
And what I was really curious about was the contractual agreement you have with the farmers. I mean, do individual farmers, do they request the water, or did you solicit them, or how did that work out to get your delivery system?
Well, we open up our fields for farmers who are interested in leasing our fields. We charge a rate that is less than market, mainly because we're putting wastewater on it. And then we provide all the operations and maintenance of all the pivots, and we provide them the water, and they get to grow the crops that we tell them they need to grow. And we have a certain crop rotation that has to be met in order to maximize the nitrogen uptake. But it's mostly corn, alfalfa, and we use potatoes as our rotation crop to regenerate the soils. And so it's been a system that's been going on for many, many years, and our growers really like it. And I think they're really going to like it when we improve the water quality that's going out to the fields after we get our new system in place.
Representative Doer.
Thank you, Madam Chair. I'm curious, I don't know anything about farming, so this might be a dumb question, but
there are no dumb questions.
How do you deal, I assume when you're washing the vegetables and whatnot, that pesticides also come off into the water, and how do you deal with that?
You know, that has not been an issue for us. If it does come off, there's very little of it in there. We test all of our wastewater before it goes out onto the fields. We have requirements that have to be met with ecology. This is an ecology permitted facility. And so that has not been an issue in the past 25 years.
Wow, very interesting. Thank you.
All right. Seeing no further questions, let's move to, thank you so much. That was really great. Great work.
Thank you.
We can move to Jonathan Lewis from Klickitat Valley Health.
All right. Can you all hear me?
We can.
Great. Well, thank you for having me. I can't even believe all the amazing projects that we've just watched here. You all must be really proud of the work that you're doing for Washington State and the momentum that's happening. Really going to shift gears from industrial symbiosis. We're just a little hospital here in Goldendale. I don't know how many of you know where Goldendale is, but it's sort of a backwater down in the bottom of Washington State. About 3,000 people live in town here. And our economy's kind of been stagnated since logging died in the 90s, and then our aluminum plant shut down in 2001. So we've been struggling along. So the idea of, even thinking about industrial symbiosis or district heating and cooling is kind of crazy talk for a small town, but I'll kind of tell the story of how we got where we're at. So I got to the hospital here in 2017 and began looking at some of the aging infrastructure. The facility was built in 1949, so things were getting pretty old. And looked at doing some energy projects. Right away, we did a full LED lighting conversion with a Department of Commerce energy efficiency grant. And then our local representative, Representative Mossbrucker, got to go on one of those Denmark trips. And she was super excited about it. When she came back, she had a deck of slides and had a meeting at the local PUD to talk about all these neat things that she saw. There were 3 of us that showed up, and I was one of them, and got super excited about what might be able to happen. So the year after that, we brought in the Center for Sustainable Infrastructure to do a value planning workshop, mainly around challenges with aging infrastructure that the schools had, that the city had, the county had, and the hospital. So all those agencies got together and kind of just went over their sorrowful story of how bad things were. And we talked about ways we might be able to work together in that kind of collaborative effort that CSI is really into, and solve some of our problems. So Reese was the one that came up with this idea of the Goldendale Energy Exchange. He came up with the term. And out of that workshop, we thought of these internal projects and how we could kind of work together on those, and how some of those projects could be benefited by a microgrid that would support the electrical infrastructure and add to some resilience. And then also an idea of district heating and cooling. We talked about biochar, the waste products in our forests, and fire risks, and all those things. Just put it all on the table. It was really exciting. And then in the 2020 legislative session, we got a appropriation to do the kind of microgrid ready piece at the hospital. So upgrade our electrical infrastructure on our oldest switchgear that's really quite dangerous. I had someone say, well, why don't you ask for a hydrogen fuel cell with that to make the project more attractive? And so we have a hydrogen fuel cell that's on order. It's 100 kW, and it will help with the emergency power backup at the hospital. All of that switchgear and everything is under the supply constraint problems, so we won't see things until about August. But working with the Department of Commerce on their smart grids program, they're administering that legislative appropriation that we got. The appropriation also included a feasibility study around the district heating and cooling concept that would potentially tie the school and the hospital together on the cooling and heating side. They came up with there's not enough shared benefit on tying those buildings together, but there was a great deal of benefit in doing ground source heat pumps on those campuses independently. And the ground source heat pump would be a 93% carbon reduction for the hospital. So really a huge project. And so all of our energy efficiency projects that we're doing currently to bring our systems up to date, we're trying to make them, again, ground source heat pump ready. That feasibility study also really helped us get ready and queued up for an energy storage for social equity technical assistance grant that we got from PNNL. And PNNL helped us leverage the ability to apply for a FEMA BRIC grant for the microgrid, which would be a megawatt scale solar and battery microgrid that would tie the school and the hospital buildings together. So we've submitted everything to the Washington Emergency Management Team. They've packaged our project with the other projects in Washington, and it's in FEMA's hands now, and we're seeing where that will go. That's kind of where we're at right now. Opportunities definitely are hard to come by in small little rural communities. So we're hoping that some of the work that we're doing and the relationships that we're forming here can be examples to the other 39 critical access hospitals around Washington State and other rural communities. So thank you all again for your work and for having me here today, and open for any questions.
Are there any questions? All right, well, I'm glad you attended Representative Mossrucker's presentation. I actually went on that Denmark trip with her, so yeah, thanks for sharing. All right, I think we can queue up Mike Werner from Qualterra, and then we'll wrap up.
All right, he's in the Zoom room. We're just getting the video going.
There we go. Hi, everybody. Let me share my screen real quick. Before I get started, I want to make sure everybody can see my screen and hear me okay?
We can. Please proceed.
Right. Thank you. Thank you very much for the opportunity to be here. Thank you to the chair as well as the committee. Also want to thank Rob Duff and his team at Commerce for supporting everything around industrial symbiosis. We are one of the awardees, and it has been a huge help to our organization to continue to research the impacts of biochar and industrial symbiosis. So a little bit about Qualterra. At Qualterra, we're really focused on really three things, and that is food supply, soil health, and climate change. As you know, there are 8 billion people who live on our planet today. The land masses all combined, only 12% of that land mass can provide food for those 8 billion people. And according to Reuters recently, about 30 soccer fields of soil is lost every minute due to erosion from different factors, wind, water. And we know that our climate is kind of challenging us all, and especially farmers and growers. So at Qualterra, what we're taking an approach around is really better soils, better plants, better world. And we have 3 distinct technologies, one around biomass processing, industrial symbiosis, clean plant propagation, and that really talks to growing plants in environments where they can grow healthily and quickly and reliably for farmers and growers. And finally, the ability to evaluate those plants to make sure that they're healthy and genetically confirmed, but also test additional crops that are already out in the fields. And for example, in Washington State, there's a virus called little cherry virus, which we're a reference lab for testing, that has caused about $115 million of damage economically to cherry farmers over the last 5 years. But specifically to industrial symbiosis, this is a picture of one of our biomass processing units. And this biomass processing unit is run on software. It's highly automated, really can run for hours on end without really anybody being attended to it. But what's exciting about it is it has the versatility to process many different types of waste. Wood, agricultural waste, wheat straw, rice husk, thistle, hemp, hops. We have processed, using our technology, all of these different materials to create clean energy and biochar. The most important thing is to really eliminate that waste, because when you think about what's happening in our environment, is that if that waste doesn't go away, it's either going to decay and become carbon in the atmosphere, or potentially it's going to be burned and become carbon in our atmosphere. And what our technology really does, especially in the forestry and the agricultural industry, is allows people to use our technology to eliminate that waste, put that biochar through carbon sequestration into the ground, as well as grab that renewable energy to heat facilities locally. The heat from this facility costs about 3 to 5 kilowatts of power to really run the machine, but it produces 80 to 100 kilowatts of power based on the biomass. Woodier biomasses produce a little more energy, a little hotter, a little more energy going out, whereas wheat straw and other agricultural biomasses, they tend to be a little lower in the energy profile, but still very efficient. But that biochar that we produce, especially that agricultural-based biochar, seems to have a lot of exciting properties to it. This slide here really references what our biomass processing units can do. So they're the size of a cargo container. They're very portable. They're very mobile. And they can process about 450 tons of biomass each per year, creating about 112 tons of biochar. But when you grab the energy from the units and you grab that biochar and sequester it in the soils, the CO2 offset for a system like this is about 600 tons per year. One of the things about the technology that's important and that we've done a lot of research on is what is our footprint to build one of these units? Just because we can build a technology that has the ability to address climate, what is the downside of producing that? And how do you pay that carbon burden off? And so what we've done is a study on how that looks. We've gotten some third-party feedback on that as well. And after running one of our biomass processing units for 1.36 months, you pay off that carbon burden and are carbon negative from then on when you produce biochar and renewable energy with our units. So coming back to that biochar, crop residue, like for example, wheat straw. These are studies across rooting and fruiting and leafy green vegetables that showed 50, 60, 80% increases in yields across a variety of different crops. And so it's easy to look at a bar chart and say, okay, what does that look like? But what does it look like in the field? And so this is the tomato study. It was done at Schreiber Farms here in Washington State. It's a third-party research farm. These are tomatoes side by side. The ones on the left were untreated. The ones on the right were treated with our biochar. What's important to note is that at about 130 days where these are at, these plants on the right are ready to fruit. The plants on the left are not. So all of the energy, if you get to a higher, faster vegetative state, all of that extra energy can be driven towards fruiting. So higher quality yields, higher quality fruits. And obviously we did some additional studies and showed that the sweetness, the bricks in those tomatoes was vastly improved using biochar as well. In addition, a couple years ago, I went out with a honey crisp apple grower in the Yakima Valley, and we put biochar into 800 New Start Whip Honeycrisp apple trees. Each one of these little dots is an apple tree in about 18 to 20 acres of apple trees. And then after about 5 months, we kept seeing that they were greener and bigger. We had a company come through and do what's called a canopy study, and they drive four-wheelers through and they take pictures of the canopy. And they sent us this map back. And they basically said, well, whatever you're doing up there where it's red, and I still don't understand why they use red for agriculture. I would think that they would mean green would be good. But the important thing is that there was about a 20% increase in canopy in about 5 months after planting. And so it's important to know, what does that mean? What does 20% increase in canopy mean? We asked our customer that question, and he said, that means I'll harvest those plants potentially 1 year earlier than I will the rest of the orchard. And so I want you to look at real quickly this area right here in yellow. At the end of this line, we ran out of biochar. We just ran out of it. But this is the same place right here. And I know it's a fuzzy picture, and I apologize that we don't have great pictures, but I don't want you to look at the trees. I want you to look at the shadows. And this is what 20% looks like when you look at a canopy. It is a huge difference. You could see it when you walked, and it just dropped. And it was something that we noted in our research. We are affiliated with Washington State University. Our Chief Science Officer, Dr. Amit Dhingra, is actually head of horticulture sciences at Washington State, at Texas A&M University, as well as an adjunct professor at Washington State University. And so he agreed that most likely these trees would be harvested, the apples from these trees would be harvested about a year earlier. And finally, the biomass processing unit that I showed earlier, this is our facility in Spangle, Washington. We just delivered one of these biomass processing units to Vaughan Timbers. This is actually the owner of Vaughan Timbers right here. His name is Russ Vaughan. And we delivered this about 2 weeks ago. And behind us in that big green stack is basically the shavings from his planing operation for his laminate timbers are all captured up there. And right now he's taking those away, basically hog fuel, to be created into pellets and burned, shipping those using diesel. He's going to take those shavings, He's going to auger them into our unit. We are going to use a process of pyrolysis and gasification to burn those down, and he is going to create biochar, and he is going to capture that renewable energy that is created from that process and use it on site to heat his renewable energy kiln, which we expect will decrease by 90% his use of natural gas that is currently heating his kiln. And so this kind of the whole, I would say, when you think about industrial symbiosis, this is exactly what our system does. It takes a waste product. It creates valuable resources in the form of energy and biochar, and it helps Russ accomplish one of his important missions, and that is to be a carbon responsible, carbon friendly forestry company. Finally, in closing, this is our facility. We own a facility. I'm sorry it doesn't look too beautiful here. It's actually cold over here in Spangle, Spokane, Washington still. But we have about a 77-acre research facility. You can see 3 biomass processing units over here that are actually, we're turning them on right now, actually, I think tomorrow, and we're going to start producing more biochar and renewable energy. We just moved to this facility, as well as this is one of our facilities. This is a greenhouse as well, so we're going to do some additional testing on different plant types here. We also have a plant propagation laboratory in Pullman, Washington, and then a greenhouse operation where we grow out all of our plants for the, I would say, the orchard and berry industries and hop industries, actually in the Sunnyside area. And so just a little more. Qualterra, we do grow quite a few different varieties of apples, cherries, grapes, hops, berries, and we have the capacity to produce millions of plants every year for the industry as well. With that, I wanted to see if there are any questions.
Representative Doer and then Representative Dye.
Thank you. Fascinating presentation. Can you tell me how much each unit costs?
Yeah, so I'm just going to stop share this one second. Each biomass processing unit costs about $425,000. There are additional integration costs, and it depends on how different people want to use them. Do they want to capture the the renewable energy, or do they just want to get rid of biomass? And so if that capture of a renewable energy is probably another $50,000 to integrate, but about $425,000 for the unit. The units are built here in Spokane, Washington. We use a contract manufacturing organization called Highwood Global. And so that's hopefully that answers your question.
Thank you. One more question. Does the quality of the biochar change with what you use to produce it?
No, that's a great question, and that's an important question. What we've done, and our technology is about 10 years old. We've been building this technology for quite a while. And because of the software that's built into our system through that automated process, we can produce the same type of biochar and the same quality of biochar and the same characteristics of biochar based on the biomass almost consistently every time. So the biomass itself, so whether it's wood, which is a little higher in lignin and is going to have a little higher carbon content, is going to be a little bit different characteristically than something like wheat straw, which has really no lignin. It's higher in silica. And it's going to be something that's going to probably come in at about 64% carbon. But when we start processing each of those materials as well as others, their characteristics will mostly remain the same.
It's fascinating. Thank you.
Thank you for your question.
Representative Dye.
Thank you, Madam Chair. A couple of questions real quick. In Eastern Washington, the wheat industry has been successful in converting over half the acres to direct seeding systems, which really is a whole different paradigm of farming, where we utilize the nutrients that we've invested into the plant. And the straw isn't a waste product, but indeed it's the thing that feeds the soil biome. And when those animals get really a good population, then we have actually increased the organic matter of our soil by double in the 20 years that that conversion has happened. And I would say that it's one of the greatest accomplishments of Dr. Jim Cook's research that won him the Wolf Award. So in that regard, that's one thing, is that, you know, the biochar, what does it do to that nutrient profile in the end product? And then the second thing is that when you're doing a soil additive, cost of shipping is usually the trigger point where you can't afford it. And I know that, you know, since direct seeding has caused acidification in the seed road, we had been looking at sugar lime that's available, but it's costly to ship. It doesn't pencil. So at what point are you suggesting that your shipping is going to become affordable to the agricultural systems, and to, you know, what happens to the to those direct seed systems? Are we going to lose very critical elements that are making the direct seed system really make magic in the soil health profile?
Well, if I could address the shipping piece, the way we're manufacturing our biomass processing units, what we're trying to do is put our units closer to the biomass, cutting down the shipping. And in agricultural systems, our objective is to actually place them in and around farms where they can actually, say, for example, a hops farmer, they have a lot of waste. Our hope would be is they would take that waste with the biomass processing unit at their location, at their facility, so they're not shipping anywhere other than taking the waste from their farm, processing it through the biomass processing unit, capturing that energy for things they need there, and then immediately taking that biochar directly out to their farms. With regards to broader application of biochar, one of the things that we're hyper focused on with our application is high value crops like apples, like cherries, hops, grapes, where there is enough value, because, you know, the cost for a wheat farmer or a broad agricultural farmer to use biochar right now is probably prohibitive. It is. For the reasons why you mentioned. So what we're trying to do is really co-locate our systems and co-locate that industrial symbiosis proximal to really eliminate that transportation and to improve the efficiency of agricultural systems around farmers and growers. Does that help answer your question? I want to make sure I answered it.
Yeah, you did. Thank you very much. I appreciate it. And I just, I hope for the wheat industry that we have more and more farmers value the residue as a real element of our circular economy in the system itself, because shipping is impossible for soil additives like that.
It is. Thank you.
Great. Any further questions? Okay, seeing none, we'll wrap up. This has been really fascinating, great, and I really appreciate all who participated. Jacob did remind me that we probably will come back together for about a half an hour to talk about an interim plans. I think we're required to do that. So at some point we'll get that scheduled before Sine Die, and folks will be able to talk about other sessions like this that they'd like to see us do in the interim. All right. In the meantime, thank you, Leo and Jacob and Megan. We're excited to bring a new Megan, little Megan, into the world soon. Good luck with that. It's very exciting. And I guess we're missing Rob at this point. But we really appreciate all that you have done for our committee, and we are glad to wrap up on such a positive high note today. All right.